Hi to you watching this video. So for this video, we're going to discuss about module number 2, measurement of horizontal distances. So this module gives you a detailed procedures on solving problems involving horizontal distances and tape corrections and errors in measurement. So the first is distance by pacing. So pacing consists of counting the number of steps or paces in a required distance. A pace is defined as a length of a step in walking. It may be measured from heel to heel or from toe to toe. So it can be measured from heel to heel, from toe to toe. Okay. So in surveying, pacing means moving with measured steps. And if the steps are counted, distances can be determined if the length of a step is known. Counting strides instead of paces is sometimes preferred by surveyors. A stride is equivalent to 2 paces or a double step. Okay, so pacing or pace is helpful if you do not have any measuring device but you want to measure a certain distance. Okay, so what we need is what you call the pace factor or the PF. So it is the length of the line divided by the mean number of paces. Okay, so for example, you have here a starting point and a finish point. Okay, so to get your pace factor, you are going to walk from the starting point up to the end point and count your steps. Take note that when you are walking, you need to walk normally. It should not be faster than your normal way of walking. It should not be slower. It should be um, normal. Okay? So, chill lang. Tamang lakad lang. Hindi mabilis, hindi mabagal. Then, count your steps. Then, the length of the line, which is this, from this point to this point, is the length of the line divided by the number of steps you make or you made. Then, from there, you can now have your pace factor. So, it means that you already have your pace factor if you want to measure a certain distance. Let's say from this point to this point, you can measure that by counting your number of steps. Okay? Times your pace factor. Then you can now have um, your distance or your measurement. Okay? Next is distance by taping. So taping consists of stretching a collaborated tape between 2 points and reading the distance indicated on the tape. It is a form of direct measurement which is widely used in construction of buildings, dams, bridges, canals, and many other engineering, as well as non-engineering activities. Of course, uh, by the way, for pacing, it is not uh, it is not precise. Okay, it is not accurate. Okay, but if you want to have an accurate data, then use a measuring device. Okay, so we all know what a measuring tape is. So this is how it looks like if you are quite not familiar with it. Okay, so measuring device, this is what we use in the field. Okay, but for construction purposes, for easy handling, this is what we use. Okay, so next is distance by tachyometry. Tachymetry or tachyometry. So tachymetry or tachyometry is another procedure of obtaining horizontal distances. You have a Stadia method. So it was introduced in 1771 by James Watt of Scotland and was at that time referred as micrometer for measuring distances. Okay? So the distance is equivalent to Ks plus C, where D is the horizontal distance, K is the stadia interval factor of the instrument, and S is the stadia interval or the difference between the upper stadia hair reading and the lower stadia hair reading. while c is the stadia constant, or the distance from the center of the instrument to the principal focus. Okay, so this is how a stadia setup would look like. Okay, so you have here your transit, then you have here your stadia or leveling rod. Then you're going to uh, silip-silip from this from the telescope. Okay, so sisilipin mo siya. Then you can have your upper reading, lower reading, and middle reading. Then from there, you can now determine your horizontal distance. Okay. Sadly, you cannot do this on field because, of course, with the restriction of COVID-19 protocols. Okay. Next is distance by graphical and mathematical methods. So, unknown distances may be determined through the relationship with known distances geometrically. So, determining distances by scaling from maps or aerial photographs could also provide sufficient and accurate results. Okay. Next is distance by mechanical device. So, number one, we have odometer. The odometer is a simple device that can be attached to a wheel for purposes of roughly measuring surface distance. So, what is an odometer? So, this is the device that you attach to the wheel. Then, papagulungin mo lang yan, papaandar mo yung wheel, then it will now record the measured distance. Next, we have the measuring wheel. So a measuring wheel is very similar in operation to an odometer, except that it is more portable and self-contained measuring device. It basically consists of small wheel which is attached to a rod and handle and can be pushed by an operator as the wheel of the device is rolled along a line to be measured. A built-in calibrated recorder automatically gives a distance readout meters and decimals of a meter. It is suitable for measuring distances along irregular or curved lines and boundaries. So actually, they are quite magkamukha. So yan. So, or similar in appearance. Okay. Next is correction in taping. So, there will be corrections in taping in terms of us measuring a certain distances. Okay, so it cannot be avoided sometimes that we can have errors due to um, different factors. Okay, so taping operation could either be of the following: taping to determine an unknown length, or taping for the purpose of laying out a required or specific length. So magkaiba yan. Pag sinabi nating determining an unknown length, we have 2 points and we are going to determine the distance between those 2 points. Now, when we say laying out, you already have your specified length from point A. We need a, let's say, 20 meter. From point A, 20 meter going north. So that is laying out. Nililay-out mo na. Meron ka ng distance. Okay? So that is the difference between those two. So regardless of which of these two categories is involved, there are some corrections which are applied to the original measurements to determine the correct and more accurate length. So the first rule, when a line is measured, take note, this is measured. When a line is measured with a tape that is too long, if it is measured and if it is too long, then the corrections to be applied would be by adding. Measured, too long, then we will add. Okay? Rule number 2. When a specified or required length is to be laid out with a tape that is too long, the correction are subtracted with the known length to determine the corrected length to be laid out. Okay? Take note, laid out, too long, this time it is subtraction. Laid out, too long, subtraction. And rule number 3, when measuring or laid out lengths with a tape that is too short, the corrections are applied opposite to those that stated in the first two rules. Okay? So, pag measure too short, minus pag laid out, too short, plus. Okay? So, ganun yan. So, when measuring with tape too long, add. Tape too short, subtract. Do not reverse when laying out. So, do not interchange them. Okay? So, next is slope taping. So, tape measurements may be directly along the slopes when the ground is of uniform inclination and fairly smooth rather than break tape in every few meters. This very practical method is generally preferred since measurements could be made quickly and more accurately than the horizontal measurements. So here we're going to ask the help of Pythagoras, okay, for the Pythagorean theorem. So this is a right triangle. So for example, you are going to determine the horizontal distance. Instead of measuring the horizontal distance from this point to this point, then lilipat ka, this point to this point, horizontal na naman. This point to this point, lilipat ka ulit. Pag natapos ka dito, pakat-cut na horizontal distance, what we can do is to simply determine the diagonal distance. Then from there, using cosine function, it is adjacent over hypotenuse. Therefore, we can now solve for the distance h. Okay? So, yan. Okay, so ito na yung ating mga correction. So, these are now the correction that needs to be applied. So, correction due to incorrect tape length. Okay? So, there are times that your tape is not accurate. When we say maybe your tape is already old, or there were some factors that caused the tape to elongate or to not be accurate. Okay? So, if the tape is due for correction due to its length, then the absolute value for the correction per tape length is determined from the difference between the true or the actual length and the nominal length of the tape. So the actual length, ito yung mismong length niya, and the nominal, of course, it is yung nominal. Okay? So for that, it is the true length minus the nominal length. Okay? So for the CL, it is the total correction to be applied to the measure length. Of course, pag magme-measure ka, sabihin natin 150 meters ang i-measure mo, pero yung tape measure mo is 50, magkakaroon ka ng tatlong correction. Okay? Kasi yung every measurement, there is an error. Okay? There is an incorrect reading. So you need to correct those reading per measurement. So CL is equivalent to the correction times the measured length divided by the nominal length of the tape. Okay? So ganun lang naman 'yon. Don't worry, we will be using, or we will be having examples later. Let's just first finish or run down the equations, okay? And the principles. Correction due to slope. So when distances are measured along the slope, the equivalent horizontal distance may correspondingly be determined by applying an approximate slope correction. Okay? So CH, it is the slope correction, or the difference between the slope length and the horizontal distance, is equivalent to h squared over SD. H is the difference in elevation between A and B. So when we say elevation, this is elevation 1, this is elevation 2. Magkaiba sila ng height, or magkaiba sila ng location, vertical location. Okay? So S is the measured slope distance between point A and B. So D is the equivalent horizontal distance AC. Okay? So for gentle slopes less than 20, it is safe to assume that the slope distance is approximately equal to the horizontal distance. Okay? Which is CH is equivalent to H squared over 2S. For the slope, it is H divided by D times 100. Okay? For steep slopes, 20 to 30% range, use this formula. CH is H squared over 2S plus H raised to the fourth over 8S cubed. For very steep slopes involved, such as those greater than 30%, sine theta is equivalent to H over S, D is equivalent to cosine theta, and CH is equivalent to S minus D. Therefore, this is will be our working equation. So CH minus S cosine theta, or factor out S, CH is S times quantity 1 minus cosine theta. Next is correction due to temperature. When our measuring devices are being made, it is being made at a certain temperature. But of course, when we go out there in the field, it is not always the case that the room temperature when the material or the uh, equipment was made is the same as the temperature on the field. It can be the case that mas mainit sa field or mas malamig. If it is too hot, then the material will expand. If it is too cold, the material will compress. That's why we have a correction due to temperature. So the tape lengthens as the temperature rises. So pag mas mainit, humahaba. Na umiikli pag mas malamig. Okay? So the correction due to temperature is equivalent to alpha times T, the observed temperature of the tape at the time of measurement, and T is the temperature at which the tape was standardized. Okay? So actual and minus the temperature when it was standardized, minus the length of the tape. Okay? Letter D, correction due to pole. Okay. So the correction due to pole, for example, going back here, you are to this to measure this point here up to point here. So pag nakatayo yan, may naghihila dito and may naghihila dito. To make the tape horizontal, hihilain dito and mas hihilain dito. Because if you're not going to exert effort at both ends, magkakaroon tayo ng tinatawag na sag. Okay? Magkakaroon tayo ng tinatawag na sagging. No, wala. Sorry. Magkakaroon tayo ng sag in measuring tape. Wala. But anyways, yung pag sinabi nating may sag in measuring tape, imbes na horizontal siya, magkakaroon siya ng parang curve. Okay? It will be concave upwards. Okay? So, para maiwasan natin yon and magkaroon tayo ng horizontal straight line, mag-a-apply tayo ng extra effort at both ends. So, the correction due to sag is the difference in length between the arc formed by the tape and the subtending chord. In determining this correction, the arc is assumed to be a parabola and is computed with sufficient precision by formula. So, CS is equivalent to W squared L cubed over 24P squared. Since W is equivalent to WL, or W squared is equivalent to WL squared, by substituting this to the equation 1, we obtain W squared L over 24P squared. So we cancel L squared. So CS is the correction due to sag. W is the weight of the tape per unit length. Okay? Per kilogram per meter. And W is the total weight of tape between supports. L is the interval between supports or the unsupported length of the tape. When we say unsupported length, okay, Pag itong tape binuhat dito at itong tape binuhat dito, then our unsupported length is the distance between those supports. Okay? If yung tape is being carried on this point and it is being carried on this point, therefore, the unsupported length is only this. So that is your unsupported length. Okay? Next is correction due to wind. So a strong wind blow perpendicular to the direction of taping will move the middle and unsupported portion of the tape to one side of the line measured. This introduces an error to the measurement which is similar to the effect of sag but is usually much less. To avoid this type of error, it is preferable not to undertake any taping work during windy days. If cannot be avoided and the measurement has to be done on the windy days, effort should be taken to support the tape from being affected by the blowing wind. Okay, so there is no correction for that. Correcting formula. Next is correction due to normal tension. So the normal tension is the amount pull required to make the endpoints coincide with the mark points of the pavement. So Pn is the normal tension of the pool which will eliminate the effects of sag is equivalent to 0.204 W square root of AE over the square root of Pn minus Ps. A is the cross-sectional area of the tape, E is the modulus elasticity of the tape, and Ps is the standard pull of the tape. Okay? And combined corrections. So combined corrections, the corrections for the effect of incorrect length of tape, temperature, tension, slope, and sag may be combined as a single net correcting for per tape length. Each correction is computed separately and it is important to identify which correction tends to make the tape too long or too short. Since the sign of each correction can be determined during computation, it is then a matter of adding these quantities algebraically to arrive at a single and overall correction to lengths, which are measured or laid out. So, it can be a case na nagkasabay-sabay yung correction natin. There might be a correction due to incorrect tape length and correction due to slope. And there is also a correction due to temperature. Okay? And correction due to pull. So what am I trying to imply is hindi possible na isa lang correction, possible that there be a combination of correction, but what's important here is you compute them individually. Okay? You treat them as individual correction. Okay? So let's now try our problem. So we solve this handwritten. Okay, so we have here the illustrative problem. A 45-meter course, AB, on a level ground was placed by a surveyor on the purpose of determining his pace factor. So the number of paces for each trial are taken are shown in the accompanying tabulation. So this is your tabulation. So for the first trial, 50 paces. Second, 53. Third, 51. Fourth, 53. 5, 52. Sixth, 53 paces. Okay, so the first is to determine our pace factor. So if we are to make a diagram, so this is the 45-meter course. So that is the 45-meter course, and we have here the number of paces. So for letter A, first thing we need to do is to determine our average. Okay, so kunin muna natin yung ating average. So average is equivalent to 50-50. So 50 plus 53 plus 51 plus 53 plus 52 plus 1, 2, 3, 4, 5 plus 53 divided by the number of times. So you have 6 trials divided by 6, and that is equivalent to 50 plus 53 plus 51 plus 53 plus 52 plus 53 over 6 is equivalent to 52 paces. Okay, so to determine the pace factor is equivalent to the length divided by the average pace, okay, or the p average. So this is equivalent to, what is the length? It is 45 meter divided by 52 paces. Okay, so this is equivalent to 45 divided by 52, 0.865. So 0.865 meter per pace. Okay, so that is now the pace factor of the surveyor. Okay, so letter B, if the surveyor then took 771, 770, 768, 770, 772, and 769 paces in walking an unknown distance CD, what is the length of the line? Okay, so for letter B, we have here a line CD. So we have here line CD, and we do not know the distance. Okay, so for the average again, for the average distance, for the average pace, so P average is equivalent to 771 plus 770 plus 768 plus 770, 1, 2, 3, 4, 1, 2, 3, 4, 772 plus 769 divided by 1, 2, 3, 4, 5, 6. So there are 6. Okay. So the P average is equivalent to 771 plus 770 plus 768 plus 770 plus 772 plus 769 divided by 6. The average, pace average is 770 paces. Okay. Now for the pace distance, okay, for the distance CD, for distance CD, it is equivalent to the pace factor times the P average. Okay, P average times the pace factor, and that is equivalent to, what is the P average? 770 paces. 770 paces times the pace factor of 0.865 meter per pace. So pace will cancel out. Line CD therefore is equivalent to 0.865 times 770, and that is equivalent to 666.05 meters. Okay, letter C, assuming that the tape length of line CD is 667, determine the relative precision of the measured of the measurement performed. Okay, so for the relative precision, C, relative precision is equivalent to the tape distance minus the pace distance divided by the taped distance. Okay, so what is our tape distance? The tape distance is 667. So 667 minus the pace distance, which is 666.05, divided by the tape distance, and the tape distance is equivalent to 667. Okay, so we have 667 minus 666.05 over 667, and that is equivalent to 19 over 13340. Okay, and we need to convert this into 1 over its denominator. So 1 divided by 19 is equivalent to 1. Then 13,340 divided by um, 19, that is 702. 702. So the relative precision is around this. Okay. Okay, so we have here problem number 2. So a line was determined to be 2,395.25 meter when measured with a 30-meter steel tape supported throughout its length. Okay, so we have here a 30-meter steel tape. 30-meter steel tape supported throughout its length under a pull of 4 kilogram and at a mean temperature of 35 degrees Celsius. So determine the correct length rather, if the line of the tape is used is of standard length at 20 degrees Celsius. So there is a correction for due to temperature and under a pull of 5 kilogram, and there is a correction for pull. The cross-sectional area of the tape is 0.03 centimeters squared. Its coefficient of linear expansion is 0.0000166 over degrees Celsius. And the modulus of elasticity of the steel is 2 times 10 raised to 6 kilogram per centimeter squared. Okay? So we need to determine the correction due to pull and the correction due to temperature. Okay? So first off, we have the correction due to temperature. And our formula for the correction due to temperature is alpha times the measured temperature minus the standard temperature times the length of the measuring device. Okay? So what is the coefficient of linear expansion? That is alpha. It is 0.001234. 00116 per degree Celsius times what is the measured temperature? It is 35 minus the standard temperature of 20 degree Celsius. So Celsius will cancel out times the length. What is the length of our what is the total length rather? What is the total length? What is the total length? It is 2,395.25 meters. Okay? So, yan. Or pwede rin naman na ang gawin natin dito is the length, but we're still going to no. Yeah. So, tama. So, 2,395.25 divide, that is equivalent to 0.000016 times 35 minus 20 times 2395.25. And that is equivalent to 0. Okay, so may kulang lang yung ano natin na input. So it is 0.000116 times 2,395.25 times 35 minus 20. And that is equivalent to 0.417. And it is positive. That is in meters. Okay. Next, what would be the other correction? It is due to pull. So correction due to pull is equivalent to the pull or the measured pull minus the standard pull times the length over AE. So what is our measured pull? Our measured pull is 4 kilograms. So we have 4 minus the standard pull of 5 kilograms times the length. What is the length? The length is equivalent to 2,395.25 divided by AE. What is the cross-sectional area? It is 0.03 centimeters squared times the modulus of elasticity of 2 times 10 raised to 6 kilogram per centimeter squared. So centimeter will cancel out, kilogram will cancel out, and we are left with meters. Okay, so we have 4 minus 5 times 2395.25 divided by 0.03 times 2 times 10 raised to 6, and that is equivalent to negative 0.03, so magiging 0.04 kasi 399. Okay, so 0.04, and that is negative meters. Okay, so 3 decimal sana. So ito yung 3 decimal natin, magiging 4. Iko-convert niya sa 4. Okay, so we can now determine our correct length. Okay, so for the correct length, it is equivalent to 2,395.25, and this is tape too long, so kaya siya positive, so 0.417 tape too long, and this time it is 0.04 meters. Okay? Okay, so 'di ba sabi natin sa previous earlier discussion natin na if the tape is too long, dun sa correction in taping natin, if the tape is too long and it is being measured, hindi siya being laid out. If it is being measured, if it is tape too long, it is going to be added. So this time, the correction due to temperature is tape too long. So we have too long and we have too short. Okay, since we are measuring, if it is too long, it is going to be addition. So plus 0.417. And since we are also measuring pa rin, tape too short is going to be subtracted, 0.04 meter. And therefore, the correct length is equivalent to 2395.25 plus 0.417 minus 0.04. Therefore, the correct length is 2395.63 meters. Okay? This is the correct measurement. But if it so happen na when laid out, ang gagawin natin, this 0.417 would be subtracted, while this negative 0.04 will be added if it so happen that it is to be laid out. But in this case, it is tape measured, distance measured. So our final answer is 2,395.63 meters. Okay, so we have here problem number 3. A 50 meter steel tape weighs 0.04 kilogram per meter and is supposed and is supported at the end points at 8 meter, 25 meter, and you also have here the 40 meter mark. If a pull of 6 kilogram is applied, determine the following. A. Correction due to sag between 0 to 8 marks, 8 meter to 25 marks, and you have 25 meter to 50 meter mark. Okay, so what is the formula for sag? Okay, so the correction due to sag is equivalent to W squared L cubed divided by 24 P squared. Okay, so let's consider the 0 to 8 mark as CS1. So correction due to sag 1 is equivalent to, what is our W? What is the weight? So it is 0.04 kilogram. 0.04 kilogram per meter times the length. What is the length? 0 to 8 meter. That is definitely 8 meters. So 8 meters. So this is squared. This is cubed divided by 24 times P. What is P? Our P here is 6 kilograms. So we have 6 kilogram. And this is raised to the second power. Okay. So kilograms squared, cancel. Meter squared, may matitirang isang meter. Therefore, the correction is in meters. So, CS1 is equivalent to 0.04 times 8, 0.04 squared times 8 raised to the third power over 24 times 6. So, that is 0. No, kulang. This is squared as well. So, that is 0.00095. 0.00095. Okay. Next, we have CS2. CS2 is equivalent to, same, we have 0.04 kilogram per meter quantity squared times the length. We have 25 to 8. So, 25 minus 8, that is 17. So, 17 meter raised to the third power divided by 24 times 6 kilogram per 6 kilogram squared. So, cancel out si kilogram, meter squared will cancel out, and meter ang matitira. So, palitan lang natin si 8 ng 17. That is 0.00 009 1. Okay, so this is meters, this is also meters. And the next is we have CS3. So CS3, we have 25 meters. Okay, so 0.04 kilogram per meter quantity squared times 25 meter quantity squared divided by 24 times 6 kilogram quantity squared. So, matitira ulit is meter. So, palitan lang natin to ng 25. That is equivalent to 0.0289. Okay? Meters. So, that is the correction due to sag. Ito, this is letter A. Okay? Next, letter B, the correction due to sag for the one tape length. Okay? So, for one tape length, ibig sabihin from 0 to 50 meter. Why? Because it is a 50 meter steel tape. Okay? It is a 50 meter steel tape. Magkaiba if, for example, this is 0 to 25, 25 to 50, then another 0 to 50. So, ibang one length here and another full length here. So, magkaiba yon. So, this time, the 50 meter steel tape is only this. So, we're only going to consider this three here. So, CS is equivalent to CS1 plus CS2 plus CS3. And that is equivalent to, what is CS1? 0.00095 plus 0.0091 plus 0.0289. And that is equivalent to 0.00095 plus 0.0091 plus 0.0289. That is equivalent to 0.039 meters. So that is the correction due to sag. Or pwede naman since this is pwede naman gawin natin 4 decimal. So tulad nung nasa module nyo, I think. So pwedeng 0.389. Okay? So that is 389 meters. Then, correct distance between the ends of the tape. Now, be careful with this one. Hindi ibig sabihin na positive ito, you're going to add that to your 50 meter steel tape. Okay? So, the correct distance, so that this is letter C. Correct distance, hindi porket this is positive, you're going to add. Okay? So, we have here 50 meter. Take note, instead of horizontal yung line, instead na diretso yung line from point 0 to point 50 meter, nagkaroon tayo ng sag. Okay? Medyo bumaba yung parts na yan. So, if in reality, hihilain ko yan mga yan, yung mga sag na yan, mas iikli yung 50 meter. Therefore, if it is a correction due to sag, we are going to subtract it. Okay? So, minus 0.0389 meter. Therefore, the correct length is equivalent to 50 minus 0.0389. It is 49.961 meters. So this is the correct length or the correct distance from point 0 to point 50. Okay, so we have here problem number 4. A steel tape weighing 0.085 kilogram has a cross-sectional area of 0.05 centimeters squared. The tape measured exactly at 30 meter when supported throughout its length under a standard pull of 5.5 kilogram. If the modulus of elasticity of the tape is 2.10 times 10 raised to 6 kilogram per square centimeter, determine the tension required to make the tape equal to its nominal length when supported only at the end points. Okay? So, if we are to illustrate that, the supported length is only at the end point. Okay? So, iisang correction lang yung magiging correction natin. So, what is the correction for nominal length? Okay? So, PN is equivalent to 0.204 W, the square root of AE, divided by the square root of PN minus the standard pull. Okay? Okay, so PN or the pull due to normal tension is equivalent to 0.204 times W, which is 0.85, times the square root of the area, 0.05, times times the modulus of elasticity of 2.1 times 10 raised to the 6th power divided by P of N or the pull, normal pull. So you have P of N minus the standard pull of 5.5 kilogram. So for this one, for this equation, it is a trial and error. Okay, so trial and error. So what we're going to do is I'll be inputting here a value and dapat yung in-input ko dito na value, magiging equal lang siya dito sa PN ko dito. Okay, but para hindi na natin patagalin, let's just try two values. 0.02, 0.204 times 0.85 times the square root of 0.05 times 2.1 times 10 raised to 6th power divided by the square root of, let's say 4 minus, I don't know, it can't be negative. So let's say it 6 minus 5.5 is 6 equals to 79.46? No. Okay, so we already have our answer in your module. So let's try yung value na nasa module, which is 16.75. So 16.75 is equivalent to 16.75. Therefore, so try normal pull, which is equivalent to 16.75. So, is 16.75 here, 16.75 equivalent to 16.75 and it is equal. Therefore, P of N is equivalent to 16.75 kilograms. Okay, so take note, it is a trial and error system.